list of numbers, position in the three-dimensional space and in one-dimension time, and something which moves in space with the fitting parameters. Okay, so I will just open a paint here. Let me know once you can see my paint screen.
Okay.
Because there is a lag in Zoom meeting, so I will just be as slow as I can. Can you see the Zoom screen?
Yes.
Paint screen?
Yes.
Okay. So see, vector is nothing but a arrow kind of thing which represents some number, right? So it can be 1, 2, 3, something like this. This is a vector of 3 numbers, right? But what is this? It is, so the first statement is absolutely true. It is a list of numbers because it saves the list of numbers. Okay, that is clear to you, right? Second number is what? A position in 3-dimension space and in 1-dimension time. Now, if you just note down here, this vector, if I have the vector r, say the vector r is of, say the numbers is 2 and 3. This is say vector number 1. Okay, so if I just represent this as x-axis, this as y-axis, and this is say vector number r, which is measured as 2 times in x-axis and 3 times in y-axis. Okay, let me just not put 2 dimension, only 1 dimension, 2, right? So this is say 2, this is 2. Okay, now similarly I have the vector s, which is having 3. Okay, so this is 1 dimension, this is another dimension, this is becomes my second dimension, 2 dimension, right? R and s, if I do the summation of both, it will be r plus s, this will be r plus s, right? So says this is s is 3, so what will be r plus s? It is going to be 3, right? Sorry, 2 plus 3 is 5, so it will be 5, correct?
Yes.
So this is equals to 5, correct? So this is vector nothing but r plus s. Or similarly, if I do s plus r, okay, say s plus r, say this is r and then this is s, this is r and this is s, right? Similarly, if I do r plus s or s plus r as well, s plus r will also be 5, right? If I do r plus s or do s plus r, the answer is going to be 5, correct? So this means that you can see this is 1 dimension. If I'm having one vector, this is 2 dimension, and I can have 3 dimension as well if I am having third one. So you can see, but the time, the value, the number that you are able to see, the volume measure is still constant, right? There is no change to it, right? This number 2, number 3, this is remaining the same. It is all when we are moving from R to S, the change in the vector will be available, right? So that means I can have multiple dimensions of vectors when I'm just having multiple vectors, but the time constant, the value associated to it is only 1. We cannot have R equals to 2 as well. We cannot have R equals to 3 in one single time. So either R can be 2 or R can be 3. It cannot be 2 and 3 at one single time, right? So that's why it is saying that position is in 3 dimensions of the space, but 1 dimensions of time.
Oh, I see. So I have a quick question. So vector, the time is always constant, right?
If you just don't change or update the value. But at the one particular point of time, the value can be only 1.
Oh, okay. So
We cannot have multiple values for single array.
Oh, okay. So if in each time we have like only one value, then the dimension of time will be the same.
Yes.
Oh, okay.
Clear?
Yes.
Now third point is something which moves in space with fitting parameters. Let's say for example, I have one array as R. This is R, right? If I do 3R, okay, so say this is R. If I do 3 times of R, so my array will be 1 time more and 1 more time, right? So this is how it goes. So this is nothing but 3R, right? So if I just consider this, this will be 3R. So have you noticed one thing? Earlier it was pointing here. If I do 3R, it has moved to here. That this is the area that it has covered, right? That is what it is telling me, It's something which moves in space with the fitting parameters. If I fit the 3 parameters to it, the similar 3 parameters, it will move from one position to another position. So this is multiplication of 3. If I do, r plus r, right? Then what will happen? It means, so in this case, this is r, and if I just do, this is one dimension. If I just say s, so this is s, right? And if I do s plus r, it is going to be like this. So again, you can see it is generating a one more. Let me put a color here. So you can see this is r plus s, right? It has also moved from this position to this position. So that is what it is telling. Something which moves in space of the fitting parameters.
Mm.
It keeps on moving while we do addition, subtraction over the number of vectors that we have.
Okay. Do you have the material that I can read more in this? I'm still a little bit confused about vector.
Materials. I don't have it actually,
Oh,
but
okay.
I will just search it on internet and will share it with
Yeah,
you. The best
because when
link.
I search it more like explaining like in list
This is, I think,
this stuff, I'm not sure like where the time come in like time.
this is the nice stuff. I think this is a good stuff. See,
Oh,
very well explained.
yeah. Maybe can you talk about more about vector alone? Maybe I don't get the concept of vector, so that's why.
Sure, sure.
Yeah,
Let
the
me just
time
put
is
a vector as a magnitude. Okay, how much, magnitude is how big the array is, and the direction. It is what the vector is named as. Okay, so vector as a magnitude in size. So number 2 is 2 magnitude, number 3 is 3 magnitude, something like that. And in its direction, which direction it is moving. Okay, the length shows its magnitude. So more, the length of the vector, how bigger or smaller it is. Okay, so how bigger or smaller? So this is, if the size of the vector, if the length of the vector is bigger, it is having higher magnitude. Okay, and if the length is smaller, it is having lower magnitude.
What do you mean by magnitude?
Magnitude is the value it can save.
Oh, okay.
Okay,
So
so
this
the
is
length.
like sorry. So this is like a right triangle, right? So if it is the side is bigger, then a plus b is a magnitude, right?
Yes, a plus b is a magnitude. That's why it is the longest way.
Oh wait, but then a and b is also a magnitude, right?
Yeah, a and b is a magnitude of vector a and vector b, and this is the summation of a plus b. That's why it is bigger than a and b.
Oh, okay. So each of those are magnitude, and the direction is where the arrow is pointing.
Yes. So if you do a plus b, it is going to start from a and go till b. If you do b plus a, it will start from b and it will go till a. But
Okay.
a plus b is always equals to b plus a. Can you see? Because the magnitude will not change. It is going to be
Oh,
the same.
yes. And is it the
It
time
doesn't matter.
dimension? Is it the
Sorry?
time dimension? Is it the time dimension that you told me, the a plus b or b plus a?
Correct. Time dimension is the magnitude it is referring to. And direction is the dimension.
Okay.
Okay, so example, a plane is flying along. Okay, so this is a plane, this is the wind, this is a propeller. Okay, so this is moving into this direction and wind is coming in this direction, right? So if wind is coming in this direction and the plane is trying to move in this, overall the combined effect plane will go like this. Are you getting?
No.
If the plane is going in this way without wind, and if wind is coming in this way, so the wind will also affect the plane to move, aeroplane to move, right? So same, wind is moving into, so understand this, the two vectors, the velocity caused by the propeller and the velocity caused by the wind. So wind have some energy, right? And propeller, that is the aeroplane, have the power to go straight, and wind has power to go in this direction. So if one is going in this direction and wind is giving into, so the combined effect of both will make aeroplane to move in this direction. It will be some angular way, right? Because wind is also impacting the propeller. Are you getting or no? Okay, let me try to explain again. Say you are driving if you throw a, there is a building. Are you Are you there? Hello?
Yes.
Yeah. Say you're throwing a paper from the top. Okay, this is a building of 20-story building. Okay,
Mm-hmm.
if you are throwing a paper from the top, okay, so there is a paper, and if you are throwing from the top, ideally with the gravity, the paper should go like this straight,
Mm-hmm.
correct? But due to the wind, say wind is moving like this.
Mm-hmm.
Okay, so this is the wind.
Mm-hmm.
Because of this wind, or say not like this, say excuse me, say wind is moving in this direction.
Mm-hmm.
Okay, so because of this, the instead of paper was going in this way, it has gone in this way, and paper will fall somewhere near to here instead of here.
Oh.
And this effect is because of the wind. Are you getting?
Yes.
Similarly, if aeroplane is going in this direction,
Mm-hmm.
okay, and if wind is coming in this direction, right, then overall the combined effect of the aeroplane and the wind, so this is the wind, then aeroplane instead of well going into straight way, it is going to go slightly this way.
Mm-hmm.
Are you getting? So this is the impact of aeroplane plus wind together. This
Yes.
is wind, this is aeroplane.
Yes.
Are you clear now?
Yes.
That's what it is telling. So this is the wind, this is the propeller, the combined effect is the aeroplane.
Mm-hmm.
Okay,
Yes.
so the two vectors, velocity caused by the propeller, results in the slightly slower ground speed heading towards the east and the east of the north. Right,
Mm-hmm.
so east, west, north, then the south. So this is south, this is east, this is west, and this is north. Right, so east, north. So this is east, north. Right, the
Mm-hmm.
direction. If you just understand it in clearly. So
Yes.
uh, if I just do like this is east, right? This is west,
Mm-hmm.
this is south, and this is north, right? So wind is coming in this direction, okay? Then aeroplane will move somewhat slightly like this, which is what nothing but east north, right? We call it as east north, right? So this is east north. So that is what it is telling, east of north. Okay, so
Mm-hmm.
if you watch the plane from the ground, it would seem to be sleep side away as a little. So it was just going to go in this way. Have you ever seen that happen? Maybe you have seen the bird struggling against a strong wind that seems to. Similarly, you have also observed how the birds are also struggling to fly when there is a huge wind coming against them. So that is
Mm-hmm.
also the magnitude of it.
Mm-hmm.
Correct?
Yes.
Now, this was about the vectors. Are you clear with the concept of the vectors?
Yes.
Okay. Now, subtracting the vector. First, we reverse the direction of the vector. Okay. So, this is a vector A. Okay. And say this is vector B. So, say this is my vector A. Okay. And this is say my vector. Okay. Let me just put A. This is my vector A. Okay. And similarly, I'm just doing a vector B. So, this is my vector B. Okay. Now, if I do A plus B, okay, then obviously this is going to be like this. So this is vector B, right? Now A plus B will join this. This is A plus B, the orange mark. This is A plus B, right?
Mm-hmm.
A plus B. But if I do A minus B, that means this is B. I need to make it into reverse direction. So A, B is going positively like this, right? So this is going in this direction, right? So this is positive direction, right? This is positive direction. If I do instead of B, if I do minus B, it is going to go into reverse direction. This is minus B.
Mm-hmm.
Are you getting me?
Yes.
This is minus B.
I
So
have a
if I
question.
want to do A,
Yeah, sorry. Sorry for cutting. I have a quick question. So I thought vector is just a list of numbers. So why there is different dimension like this?
yeah. So we are okay. Let me just put it down into a number way. Okay. So if you understand the numbers, okay. So this is the number line, right? And
Yes.
if I just say 1 here, then minus 1 will be exactly opposite to here, somewhere here.
Oh.
Are you getting me? So it is exactly opposite to the number. If I say -2, then if I just say +2 here, it will be -2 here in terms of numbers. This is number line, right? But instead of number line, I'm just representing my vectors with respect to my magnitude and the direction. So it is not the integer numbers. I'm representing vector with the direction and the magnitude in a way that I can form the vectors. Okay. So say this is my A, this is my B. Okay. So if I do -B, it is going to go in this direction. Are you getting now? So direction will change, right? Anything that is going straight, if I apply minus sign to it, it is going to go in reverse way. Are you getting now?
Yes.
So A minus B is going to be this. Just think of a situation. Just if you're not able to digest, just think of a situation. Okay. Say you are a person, right? You are a person. Say, okay, they say this is you. Okay. Say you are asked to move 2 steps forward. Okay. Two steps forward. 2 steps forward. So what you will do? You are at this direction right now. You are at this place, right? So 2 step is, this is say 1 step and this is say 2 steps. Okay. Then you will reach somewhere here, right? So this is 2 steps away from you. Now if someone asks you to go 2 steps back, that is negative way. So this is +2, right? So this is +2, right? Now if someone asks you to go into the reverse way, that will be -2, right? So in this case, again, if I just say ask you to go one direction back, so again you are at the number 2, and then you will be reaching out to somewhere near to here, right? So this is again -1. So you went into the reverse way, right? So it was your direction. When I asked you to go back, you went back, correct? By 1. So similarly is this. This is A, this is B. If I ask you to go back by 1 same magnitude, you will go in this direction. That is opposite to what we have asked for. So that is what subtracting means. We can also subtract one vector from another. First, we reverse the direction of the vector. If you want to subtract it, we always reverse the direction, right? I was going in this direction, but if I want to subtract, I want to have to go into the opposite direction. So this is what A minus B is. Then we add them all. So this is -B, this is A, and then if I just add this, it is going to be A minus B. Clear?
Yes. Yes.
Okay.
I think I'm clear.
Clear, right?
Yes.
Now, let's try to understand the notation. If you want to represent a tail, this is at, vector A, this is vector B. If you have a vectors represented in this way, okay, that is, this is say like this is B, and starting is A. Okay, starting point is A and reaching point is B. So this vector can be represented as A, B, and an arrow here. So this is at the tail position. This is at the head position. So we can represent vector as like this AB and the arrow above it. So this is AB vector. Vector AB we can say. So that is what the notation. So a vector is often written in bold like A or B, and the vector can be taken in as letters as is heads, and the arrow above it is like this. So this is how it is written. Here, are you clear with the concept?
Yes.
Okay, perfect. Now let's try to understand how to add the vector. So say this is vector. We can add the vectors by adding the x parts and adding the y parts. Okay. So say this is the vector 8, 13. So this is a vector 8 and this is 13. Are you getting the purple color? This is one vector, which is vector 8. This is a vector 8. Are you able to see?
Yes.
This is vector 8. This is vector 13. Are you able to see?
Yes.
Okay. Then this is vector 26. Okay. This is vector 7. Clear? Now, if I want to add these two vectors, okay, that is, how will I do that? That is 8 plus 26 will happen 34, right? So let me just try to help you to understand this 13 plus 7. So how to add the two vectors is, say this is my vector 8. Okay, this is my vector. Let me check the same example 13. Correct?
Yes.
Now, instead of this, what I can explain in this way is, let's have a directions in a way that you can easily digest. Okay, so this is 1, this is 2. From the same point, this itself, okay, I'm going to have the vector number 26 and with the vector number 7 like this. So this is my 26, right? This is what my 13, correct? And this is my 8. Now, this is my y-axis. Are you able to see? This both are my y-axis, right? And this both are my x-axis. This both was in my x-axis. Okay. That means if I am doing, this is x-axis, that is 8, 13. This is x. This is y coordinate. And what is this? This is 26, 7. Clear? Now, if I want to sum this, that is, if I want to sum this vector with this vector, okay, that I want to sum the two vectors, that is, this is one vector, the one which I'm marking out into the red color, this is vector number 1. Clear? And this is vector number 2.
Yes.
Clear? Now, if I want to sum this, then x to be summed with x and y to be summed with y. That is this way. So you can see 8 plus 26 will happen to be 34. Correct? Because x will be summed with x. And 13 plus 7 will be 20. So this is how the answer of two summation of the vectors comes into the picture, which is 34, 20. That is 8 plus 26 is 34. 8 plus 26 is 34, and 13 plus 7 is 20. So add a vector 8, 13 and 26, c. So a plus b is 8, 13, 26, 7. That is 8 plus 26, 13 plus 7. That is 34 plus 20. So if we break up the vector, it is going to like this. So we break the vector like this. Each part is a component. So say this is 7.2 and this is 2.5. This is y direction, right? And this is x direction. So this is how it goes.
Okay.
Clear? Are you clear with the addition of two vectors?
Yes.
Similarly, if I do the subtraction as well, it is going to be like this: 4, 5, 12, 2. So vk minus 1. So 12 to be subtracted from 4, 5 to be subtracted from 2. So 12 minus 4 is 8, and 5 minus 2 is 3.
Oh, I have quick question. So going back to the question list that I have in the machine learning notebook, can you open the OneNote again?
Sure.
There is a question, the OneNote, the ML study. See the OneNote that I share with you?
Yeah.
Yes.
Yes.
So there's a question on subtracting is r minus s. So I would let me guess. So I would get 3 minus 1. So it is 3 plus 1, right? And 2 minus 2 is, so it could be like 4, 0.
No. R minus s.
Yes.
So it is 3 minus 1. That is 2.
4. No.
3 minus 1 is 2, right?
But 3 minus 1 is 4, right?
Yeah. 3 minus 1 is 4. Correct. 4.
Oh,
yes.
okay.
2. And 2 minus 2 is 0. So it is 4, 0.
Okay. So hang on, let's try the below one. Using this formula, complete the calculation.
This is multiplication. This is dot product.
Oh, let me try it. So so it would be 3 plus minus 1 would be 2, and
No.
plus 2. So it would be 2, 4.
It is multiplication.
Oh, multiplication. Oh, we have
a dot
that part.
Then.
Okay, then I'll let you go back to the lecture notes. We haven't go to.
Okay. It's a dot product.
Okay. So dot is the multiplication then?
Yes, dot product is multiplication.
Okay.
So that is what we are going to cover now.
Okay.
So subtracting and addition, I think you are comfortable with.
Yes.
I need more to explain it to you on that point.
Mm-hmm.
So let's try to get how to multiply the two vectors. So
Mm-hmm.
multiplying the two vectors. See, this is how it goes. Like as I said, right? If I have one vector, three times it will be 3m. So 3 into 7. Say 7 comma 3 is my vector m, and I want to go three times. It is 7 into 3, that is 21, and 3 into 3 is 9. If I only having one direction of the data,
Mm-hmm.
right? But if I'm just multiplying vector by vector, we call it as dot product, or you can call it as a cross product. Anything that is comfortable to you. Okay, so it can be referred as dot product as well, or it can be referred as cross product as well. Both are comparatively same. Okay, so if you
I'm
have,
not understand. So what is the difference between dot product and cross
it
product?
is same, no change. It is just naming you as naming the one person with two different names.
Ah, okay. I see. Okay.
Okay,
Yes.
so this you can call dot product and you can call cross product. One is the
Mm-hmm.
same.
Yes.
Okay, so say 145 is this one. This is 145.
Mm-hmm.
Okay, say this is vector 374 and this is the vector 329, 292 and 911. If you want to do a plus b, it is going to give 3 plus 2, 5, 7 plus 9, 16, and 4 plus 11, 15. Right? But if you want to do the dot product of it, how will you do that? It is not shown here. Okay, anyways, I think it should give you the example of dot product. Okay, so if you want to do the dot product of this, it will be 3 into 2. Okay, so 3 into 2, that is 6.
Mm-hmm.
7 into 9, that is 63, and 4
Mm-hmm.
into 11, that is going to be 44. So 6
Mm-hmm.
comma 63 comma 44 will be the dot product of two vectors.
Oh, I have another question. So I think this question appear in one of the quiz. Can I control the annotation?
Yes.
Okay. Can you let me to draw on the,
How do I do that?
oh, you have to click on one of the button on the Zoom, I think.
Yeah, I just tried to give you. Can you try now?
Oh, okay. Let me, huh. Can you turn on the note? Okay. Let me control the screen.
Sure, sure. I just gave you the rights. Can you try this?
Okay, so how do you multiply, how you do dot product of a vector that doesn't have the same dimension? So for example, oh, this one is low here. Let me try to see if you have a notepad. Okay. So if I have a vector of like 3, 5, if I have another one of, for example, 1, 2, yes. So how do I multiply them together? Is it
Oh,
possible to do it?
this is a bit weird because you are trying to multiply two-dimension vector with three-dimension vector. So this is not possible.
Oh, okay. Yeah, I think I remember the question wrong then. It must be.
Hmm.
Let me double check. Can you
The
give me?
dimensions should be the same. Or, if this is the case, you can assume the third dimensions to be one automatically.
Oh,
That can be done.
oh, okay. Let me double check. I think it's on the beginning of the quiz, so it shouldn't be complicated.
Okay.
Yeah,
Yeah.
let me quickly double check. I was doing the quiz, so um, okay, it should be here. Discussion about this quiz. Mm. Sorry, give me some more. Okay, let's continue. Yeah, I'll have to look for it later. Manish?
Yeah, yeah.
Yeah, could you please continue on the dot products? I'll have to ask. Oh,
Sure, sure.
here, I found it.
Okay,
Let me share the screen with you.
sure. Let me stop sharing.
Mm,
Let me stop sharing this.
okay.
Yeah, go ahead.
Yes. So you see. Oh wait, is it in the same dimension?
Yes.
Yes.
You can easily do this, right? Minus 5 into 1 is minus 5. 3 into 2 is 6.
Mm-hmm.
And like,
Oh, you are right. Yes, you are right. So, so if I want to multiply, if I want to do the dot product, they have to be in the same size.
yes, yes.
Oh, you're right. Okay. Yeah, let's continue. I remember it wrong then. Okay.
Clear, right?
Yes, yes. Yeah, you're right. Oh, so how do you compare them? Like whether which one is larger?
So, which larger, A plus B or mod of A or plus mod of B?
Is
Okay.
it the same
So,
though?
uh, what is A plus B and then taking the modulo of it and first adding it, then first taking the mode of it. So, what is just let me check.
I
So,
thought it's the same.
yeah, it should be same, but let's try to compare.
Here, let me get back to your sharing screen. You got the question?
Yeah, yeah, I got the question.
Okay.
Let me try to understand the
Okay.
mode of A plus B is equals to mode of A plus mode of
I think it's one of the trick question because
yeah.
the
Ideally, this should be the same, but
yeah.
we never know, right? We can just cross check.
Mhm.
Yeah, I found one link. Let me try to
Mhm.
get that link answer. Just hold on a minute.
Yes. Oh, and can you explain for me the vector projection too? I don't understand a lot of the terms here.
Yeah, projection is completely a different,
Oh,
sense.
okay. I'll let you go through with the lesson. I think maybe it
Yeah,
matters to get the foundation knowledge first.
correct, correct. So we can just try to understand this in detail. Just not able to, you know, it's just okay. Now, uh, V as a both length and a V is a vector scalar. But ideally, you are right. Like how to find modulo of vectors of the same set, then A plus. How can I prove? Okay. So which one is your question? Yeah. So you are absolutely right. A plus B modulo is equals to modulo A plus modulo B. That is the correct
Okay.
answer.
Yes. Oh,
I just
I was
I just
asking.
googled it. Yeah,
Yes.
and it is the
Oh,
correct answer.
also, yes.
Would you like to share your screen again? Is there any other questions to ask? Okay,
Oh,
you are
yes.
for vector projections, right? So
Yes.
yeah, vector projection is completely different theory. We need to go through that.
Oh, okay. Yes. I'll stop sharing now so you can
Yeah, sure.
continue. Yes.
I'm sharing. Where is the dot product example? This. If I just go to the next one. Okay, fine. So I need to. be sure that this is what exactly I wanted to explain. Hmm. Okay. I think I need to share my screen.
Mhm.
Can you see my screen?
Yes.
Okay, perfect. So say cross product. Okay, that is, this is a magnitude and this is the direction. Okay, so two vectors can be multiplied using a cross product. Also see a dot product. Okay, so say
Mm-hmm.
A is this, the cross product is named as A cross B, right? Which is of the two vectors is another vector. So say this is A, this is B. If I do a cross product of it, it is going to go in this direction.
Mm-hmm.
Okay, that is the right angles to both. So the magnitude of the cross product equals to the area of the parallelogram. So see,
Mm-hmm.
this is A, this is B. So A cross B is going to be this. So, but it will keep on changing. You have to understand. Say the angle between the, the A and B is changing like this. Can you see? If the angle between A and B is changing, the cross
Mm-hmm.
product will be always the same. Say for example, uh, how can I explain this way? Say A into B. Correct, correct. So I need to say this is A, right? And
Mm-hmm.
if A and B are same, say again I'm multiplying A into A, right? So this is going to be A square, correct? So
Mm-hmm.
what is
Yes.
A square? Okay, if I just do cross product, it is going to be A square. Right? We can say A square. So which is going to be in the same direction like this. So no angle change, right? This is A and this is A square, correct?
Mm-hmm. Yes.
Similarly, if I do this is say A, this is say A, and this is say B, okay? Then A and there is the both direction and the magnitude of both A and B is different. So A cross B will go somewhere near to like this, right? So this is A cross B, okay? This is A cross B.
Mm-hmm.
Now, if the angle between A and B can be, same when A is this and B is the opposite of A, that is, this is minus A, which we call it as B. So A into minus A will give me minus A square. So my magnitude will not change, my direction will not change, it will be a straight line still, right? So that is what it is telling. So when you do A cross product of B, the area between A and B that you are able to see will keep on changing if the magnitude of the direction is changing of B. If A is kept to be same. So this is how it keeps on changing.
Mm-hmm.
Are you seeing the circle? Are you able to see? So the blue color line is the your product A cross B. And if you keep on changing the B, this is your cross product. This is how it is going to change.
So depends on the angle. It could be A plus B or A cross B or A minus B, right?
Correct. It
So
depends on
I have
how
a
the B.
question. Yeah. So from the picture, how do you know which one is A plus B and which one is A cross B?
Yeah. So A plus B is always your hypothesis. Okay. So whenever you want to do A plus B, so say this is your A, this is your B. Your A plus B will always be like this, a hypothesis,
Oh.
like this. But A cross product will be starting from the same axis and it is going to go in different direction like this or like this. Or it can go. So say this is B and this is say A. Your A plus B will always be a hypothesis like this, A plus B.
Mm-hmm. Yes.
But A cross product can be either go in this direction or can go in this direction.
Oh, I see. But I thought the opposite direction would be A minus B.
No, no. A minus B, if you do, it is going to be like this. Say this is B and this is A. If I do A minus B, then this is minus B, right? And
Oh,
this
I
is
see.
A minus B. This is A minus B.
Yes. Oh, I have questions. So it depends on the plane, right? I remember like a few weeks ago we talked about Castelar plane. So yeah, so the minus could be like in the fourth Castelar plane, something like that, right?
Sorry, I don't get your question.
Oh, let me check on the name of it because I remember a few weeks ago we talked about Castelar plane. Let me check what is the name. So you know, like you have A and B, and there's four section.
Yes, yes.
Oh, okay, I cannot find it. Castello.
You just yeah, you can just keep it with you. We can just discuss it tomorrow.
Oh, okay. Yeah, because okay. Let me see. Let me see. Oh, okay. Let me share my screen.
Sure, sure.
Let me. Oh, wait. Oh, I can share the whiteboard. Oh, okay, awesome. So you know, like before, I remember we have one question where we have like this four quarter, like 1, 2. You remember this? 3, 4.
Your screen is like yeah, yeah, yeah. So this is the Cartesian. Yeah, yeah. True, true.
Yes, yes. So
Yes, yes.
you was
Coordinates.
telling me like this one is always minus, and this
Yes, yes.
plus. This one is like
X, Y is negative and X is positive. Fourth. Yeah. So this is
so.
coordinates. X, Y, Z.
Yes. So is it related to the vector that you were telling me? Like if it's go to this direction and it always like minus b.
Uh, this is somewhere, you know, we can relate it to that way. Yeah, we can say that. True.
Oh, okay. Ah, okay. So if I want to learn about, sorry. So if I want to know about like a plus b, that is will always be in this quarter, right?
If both A and B are positive, yes, definitely. The value, the
Oh,
magnitude is positive, then it is yes.
oh, okay. So it
Magnitude is
has,
positive.
okay. So it has to depends on the value of a and b too.
Correct. Correct.
Okay, okay. I'll give you back the screen. Yes. Okay. Please continue.
So what I will do, Jen, is that okay. What I will ask you to do is okay. The Coursera course is bit confusing. Okay, so
Yeah.
we are already only 3 minutes is left for us to continue. So what I will do for you today is okay. I will just share 2 or 3 links with you today. Okay,
Mm-hmm.
this
Yes.
is explanation of this in a very basic way. Okay,
Mm-hmm.
just go
Okay.
through those things which I will share it with you, and you
Okay.
can just immediately ask me the questions on the chat, and
Mm-hmm.
then we can discuss about those into our next class if you couldn't understand the chat. Okay,
Okay.
so let
Sure.
me share all the materials of the factor, because this is bit high level. The Coursera thing is bit high level for you to
Oh.
digest for now. So
Okay.
all I need to make sure is that you are clear with the basics of the magnitude and the vectors.
Mm-hmm.
So I'm
Yes.
just going to find a very beautiful links for you. You can
Mm-hmm.
go through that, and we can just discuss
Yes.
about this into our next class.
Yes. Oh, wait. Can I share my screen for a moment? Maybe we can start with something more basic because I do
Sure.
feel overwhelmed with this too. So I have here. Let me see. Can you see my screen?
Yes, yes, I can see.
Yes, so I have here is like the basic statistic from Amsterdam, University of Amsterdam. It was recommended in my course also. So I wonder if we can, it would be better if we start with this instead. Like we will learn like regression and correlation, stuff like that. Would be better.
This is stats. This is statistics.
Yes.
Yeah, we can
Yeah,
start. No problem.
yes. So next week, let's start with this instead of the math. I think the math is too advanced for me. Do you think it's
Sure.
all right?
Yeah, I'm completely
Okay.
comfortable with this data. I'm already aware of all these theories. I'm
Yes.
okay with it.
Yes. So let's do this step because yeah, I think the math I have to do it in a few more weeks instead. Let's
Yeah,
do the easy material first.
sure.
Okay.
Okay,
Awesome.
perfect.
Yes. Thank you so much for the lesson today. Please help me send the slides. I'll
Yeah.
take a look at it. But I have a question. So in a few more weeks, can we go back to the mathematics course once we grab the basic statistic?
Yes, we can go there. Yeah.
Awesome, awesome. Thank you so much. Talk to you later, Manish. I think that's all
Yep.
I have today.
Okay. Thanks, Jen. Thank you for your
Yeah,
time.
thank you. Bye bye.
Bye.